right, well, welcome everybody. Hope you can hear me clearly, and thank you for the introduction. So yes, so today I will be walking you through everything that we've had to do at Fitch in order to put 3 different applications in production, all 3 of them using retrieval augmented generation pipelines in different contexts. The reason I wanted to give this talk is because in finance, particularly at Fitch, there are 2 very specific issues that make this very complex. One is the number of documents we publish, and I'll talk a little bit more about that soon. And 3, the fact that these documents are very similar. One thing that I want you to think of is in finance, let's think about public companies, because I think that's relatively familiar to most people. When you think of public companies, they typically will publish quarterly earnings and an end of the year report. Those reports have to follow very specific formats. They're required by the SEC to follow very specific formats in the US. So you can think of the one from the quarter Q4 of last year is very similar to the one of Q1 this year. The numbers obviously differ, but the thing that is being reported is similar, and that creates a lot of complexity when using systems that need some sort of retrieval similarity to function. So I want to start this with, once upon a time in America. I think if you're joining this session, my expectation is you either are familiar with RAG, maybe you have already tried a couple of applications, hopefully you have something already in production. But I've heard it from a lot of colleagues in other companies or even in other industries where an executive, it typically goes like this. An executive will hear about AI and they say, we have to implement AI. And one of the most popular applications is talk to your data or talk to your documents. And so they pass that mandate down, and you have your sort of VP or director level talking to all the developers saying, we need this and we need this urgently. And the first thing you do is you create a prototype or you create a POC, and things are looking great. It might take you a couple of weeks to put this together with a very basic document set. But then once it comes time to put it in production, it's not quite as useful. Maybe things fail. Maybe users don't find it to be particularly relevant or accurate. And that's where things start going haywire and everybody's pulling their hair. So what I want to walk you through today is all of the steps. We've gone through this process. And I want to walk you through all of these steps that we have implemented in order to make it useful for our users. So first off, what is the Fitch Group? I do want to, I'm not assuming that everybody is familiar with what we do, so I will give you a brief overview. The Fitch Group is composed of a few sub-companies. The 2 biggest ones, and probably the 2 most well-known ones, are Fitch Ratings and Fitch Solutions. Both Fitch Ratings and Fitch Solutions provide financial insight. Fitch Ratings specializes in credit ratings and credit risk assessment. It works in regulated environments. Fitch Solutions does not work in a regulated environment, and they offer many additional products or reports relative to Fitch Ratings and many additional types. We work across the globe. We're close to, I think this figure might be a little bit old. I think we're close to about 2,000 analysts now, operating in over 40 cities and reporting in over 150 countries. We report on countries, local governments, banks, non-banking financial institutions, public companies, loan and bond offerings, et cetera, et cetera, et cetera. The point I want to drive across is we are publishing dozens to hundreds of thousands of reports every single year. And many of our products that are external facing are offering users access to these reports via AI. So I'm assuming that if you're attending this talk, you're already familiar with RAG. I just want to make sure that we're all level set and we have a few of the key terms in common, but I'm not going to go through all of the basics. So in RAG, typically you have a knowledge set. In our case, it's sets of financial documents. You will chunk, embed, and index these documents so that you can store them in a vector database, and then you can use many different methods of searching for relevant pieces or relevant chunks. Whenever a user asks a question to your AI system, you will retrieve the most relevant ones. And then also, not necessarily, but many applications, and in our case, some of our applications as well, you may have some agentic behavior with the capability to plan or hold some memory in order to enhance your RAG application. This is the basic pipeline. If you've done any prototypes or POCs, at a very minimum, this is what you've done. You have some text data, you have to index it. You get a prompt and you retrieve the context. You pass all of that to a language model, and you serve an output to a user. There's two key components here. There's the retriever, and then there's content generation. In the retriever, somebody will ask a question, that question gets embedded, you pass the embedding to or you compare the embedding to the embeddings that you have stored in your vector database, you retrieve all of your relevant snippets / chunks, and then you use those chunks in combination with the original question to ideally serve an accurate answer to the user. So what are some of the RAG use cases, or what are some common RAG use cases? Apologies for that. So in industry and commercial applications, the most common one, and it's the one that I'm going to be talking about today, chatbots. You also have code assistants like GitHub Copilot or the one from AWS. I can't remember the name right now. In the medical field, you might use it with electronic medical records, but you can also use it for literature review and document review. That's a particularly useful application in academic environments for doing literature review. And you don't necessarily have to use it for text. You can also use it with images and doing image analysis and image processing. Now, that's all well and good, but this is the reason you're here today. How do you build a production RAG system? So there are many components, and each one of these components, in order to serve a performant and accurate system, may take quite a bit of time. So first, you need to start with data collection and pre-processing. Anything in AI and data science or machine learning and data science needs clean, good quality data. Thankfully at Fitch, because our financial analysis already depends on good, clean quality data, that might be a little bit easier than at some other companies where I've spoken to colleagues, but we still need to do a lot of data pre-processing in order to get it ready to be used in these RAG applications. You need to set up your data ingestion. Again, Fitch analysts are constantly publishing. I mean, we publish hundreds of thousands of reports every single week. So we need to have a consistent method to ingest these into the RAG pipeline. You need to have a good retrieval model setup. You need to have a good generation model setup. And this is not trivial, and I'll talk a little bit more about this later, because you also need to future-proof these technologies, and you need to make it modular. There's a lot of work in the industry that's going into enhancing these technologies, and you don't want to be stuck with a component that took you, let's say, a month to develop or even a quarter to develop, and then one of the big tech companies comes out with something much better 3 months from now, and now it takes you months to be able to incorporate the new thing. Finally, integration and prompt tuning. How do you combine all of these different systems? These systems need to be able to communicate with each other, and I'm going to show you some architecture diagrams in a little bit to drive home the point that this is not trivial. And then evaluation and deployment. These systems are dynamic. You're ingesting new data all the time. The types of questions that users are asking might be changing. You need a way to evaluate these and make sure that they stay performant. And if they don't, then you have to identify where your chain or your pipeline is breaking down in order to be able to work on that particular component as quickly as possible. Choosing a vector database, I'm not going to go through all of the vector database types that are out there, but I just want you to get from this that some are dedicated specifically for vector databases, others are multi-purpose or general use, and they now support vector search. And of course, you have your open source and you have your commercial ones. At Fitch in particular, we're using Azure AI Search and Elasticsearch, depending on the application. Some things to consider, open source or private, that might be of particular importance to your company or to your use case. Enterprise features, that's incredibly important to Fitch because our systems need SSO. We have many particular users and we have users who may not be subscribed to access to all of our data sets, and so we need ways of doing permissioning. Rate limiting, multi-tenancy, we might get peak periods when users are coming in, dozens of users at the same time, asking potentially hundreds of prompts every minute at the same time, et cetera, et cetera. All of these are very important. The key takeaway I want you to take from this slide, you don't need to consider every single one of these. And the reason I'm going to show you 3 different applications today is so that you understand that there are different levels of complexity depending on what it is that you're showing in each application. Okay, so here's where we start adding, before I showed you that basic RAG pipeline, now is where we start adding some custom steps to get it to work with large data sets and documents that are being, and data sets with documents that are being updated very, very frequently. So first, on the document ingestion side, you need potentially custom chunking strategies. One thing that you will see shortly is that at Fitch, all of our products don't have the same type of document. We have documents that have many, many dozens of pages. We have documents that might be 1 page long. We have documents that are only text. We have documents that are text plus tables plus bullet points or some other semi-structured or structured data. You need to find ways to index. Again, the retriever, you need that for every single RAG pipeline. But in pre-retrieval, when you're dealing at the scale of documents that we have at Fitch, we have in some databases, we have hundreds of millions of chunks. If you want to have a performant response to your user query, you need to narrow down the knowledge base and the search space. You can't necessarily search on hundreds of millions of chunks at the same time and expect to get an answer back in 2 or 3 seconds. One of the most common ways of doing that, and it's something that we have found very, very effective, is query routing. So we have trained custom machine learning models to identify what is the intention behind the question that the user is asking. We've done that via a technique of both prepared ground truth and synthetic ground truth. So we have had teams of analysts prepare question answer pairs with existing documents, and we use that as ground truth, and then we'll augment those synthetically with LLMs. Query rewriting, that becomes very, very useful because a lot of people intuitively still want to use language models as sort of a search engine. So somebody might just write Microsoft earnings last quarter. That is not, when you embed that, it may not give you a great response, but you can use a language model as a pre-step to take that query and augment it and make it more useful before the embedding step. Query rewriting and query expansion, both of those are an example of what I just mentioned. You retrieve your relevant chunks, and then post-retrieval, you can do re-ranking. Why would we need to do re-ranking? We actively do this at Fitch. In finance, again, somebody might ask about a particular financial metric for a country. If they don't include the specific time, depending on the use case, it might be useful to assume that they care about the most recent one that's available. So you might retrieve several different chunks for that particular country, for that particular financial metric, but some of them were reported this year, some of them were reported last year, some of them might have been reported 2 or 3 years ago. Before serving that back to the LLM as context, it might be useful to re-rank them and say, hey, the most important one is the most recent one. Context compression, you might need to retrieve many different chunks in order to serve a useful response. The chunks may contain, depending on the chunking strategy, they might be relatively long. You may not care about all of the information in that particular chunk. You can compress it in order to get the most important information. And then one important step, and I'm going to demo this very briefly later, is agents. You can have an agent step to check how relevant is the answer to the question that the user asked, or do I have all of the information that I need to answer what the user asked? If the answer is yes, you serve the response to the user. If the answer is no, you can go back to any of these previous steps and gather more information. Guardrails, I have limited time here, so I'm not going to go into a lot of detail regarding guardrails, but as you can imagine, Fitch being a financial company in a regulated environment, guardrails are extremely important. We cannot legally provide financial advice. So if somebody comes into one of our systems and says, hey, I want to buy Apple, is Apple stock, is now a good time to buy Apple stock, we need to serve back a response that says, hey, this is not a question that we're allowed to answer. This would constitute financial advice, which legally we're not allowed to provide. And obviously all of the other guardrails, making sure that everything stays on topic, making sure that neither the question or the response has any violence or any political opinion, et cetera, et cetera, et cetera. You can choose many actions to take with the guardrails. And in fact, we use all three of the ones here. We might block or retry the question with a slightly different prompt or query. We might provide a standard answer in the case of somebody trying to get financial advice, or you might decide to still look for a response, even if you don't fully clear the guardrail. So let's say if somebody's asking for confidential information that they don't have access to, you might realize, oh, this is confidential information. This particular user doesn't have permission for that, but I can still serve them information about that specific entity. Some optimization methods. The key takeaway from here is as you go up and as you go to the right, your solution becomes more and more complex. Do you need to take all of these steps for every single rack solution? Probably not. At the scale at which we are operating at Fitch, we have taken many of these. The only one that is not in production yet, but we're already experimenting with this, is fine-tuning. We haven't yet fine-tuned any of the LLMs for specific use cases, or let me rephrase that. We haven't yet pushed it to production, but we are finding that for some specific use cases, much smaller models, without naming names, some of the open source models that have significantly smaller parameters and thus are significantly faster and significantly cheaper to run, if you fine-tune them, you can still get some great responses for some specific use cases. And then lastly, the evaluation metrics. Again, I don't have a lot of time to get into evaluation metrics here, but if anybody's interested, and I have personally directed part of the team that has worked on the evaluation metrics, not only for RAG, but also for content generation. So I have a lot to say about this. If you want to follow up with me either in the questions later or personally over LinkedIn, feel free to follow me on LinkedIn. The one thing I want to say here is it is extremely important to get this right. And machine evaluations are great, but they're not a panacea. They don't solve everything and anything. You can use very powerful language models, the state-of-the-art language models. They might work 70 to 80% of the time. They don't necessarily always give you the correct evaluation. So that's one thing to consider. A lot of times you need a human in the loop, or a lot of times you need to go through the pre-work of generating ground truth in order to do proper evaluation. Okay, so Fitch use cases. Like I said, we have 3 in production. Fitch GPT is an internal one. It's only available to employees. Fitch Ratings Pro Genie, which I'll show you a little bit more later. This is available to anybody who is subscribed to Fitch Ratings Pro. And Credit Sites. Credit Sites is a subsidiary of Fitch Solutions. It's a similar application. It's also a Genie, but they have a very, very specific document set. And they have some very, very specific permissioning requirements because they have very fine-grained permissioning to all of the publications that they have available on their website. Both of these are now externally available, and we very, very frequently gather feedback from the users. So for the next 3 slides, what I want to show you is driving home the point. these systems can get very, very complex, but you don't need every single piece of complexity for every single one of these. Fitch GPT has a variety of internal knowledge bases. We also give the user the ability to upload their own documents and create their own knowledge base and be able to query their own data. For this one, we use Azure AI Search. We use, actually, this is a little bit outdated. So some of these slides are recycled from past presentations. We actually offer GPT 4.0, we offer Llama, and we offer the Claude models. And we allow for customizable AI personas. We call personas, think of it as the user or system prompt. So if you want to handle a particular use case very frequently, you can store a specific, even if you're not technical, you don't necessarily have to be technical at all. You can store your specific user prompt for that particular use case. Fitch Ratings Pro Genie, this is a lot more complex because there are hundreds of thousands of documents. We cover basically the last 3 years of research documents, everything that Fitch Ratings has published. It's external facing, so we need a lot of guardrails. For this one, our database of choice was Elasticsearch. We used intent-based routing. As I mentioned previously, we custom trained machine learning models that will classify what is the intent of the user so that we can filter down the knowledge base and also redirect to different pipelines, because different pipelines have been fine-tuned and specialized to handle specific types of questions. For this one, we're using GPT-4 Turbo and GPT 4.0. We're also using open source LLMs because some of the agentic behavior that I will show you in a bit doesn't need the most powerful models for some of these steps, and so you can make those steps cheaper and faster. Advanced retrieval techniques, everything that I mentioned previously, and then post-retrieval agents, which, like I said, use some of these open source LLMs, and I'll actually give you a basic demo of these post-retrieval agents. Credit Type Genie is very similar. It does have different type of data. And like I said, the permissioning is very specific. So the ingestion and the chunking there are many different strategies for content ingestion and chunking because the type of data that they have on their platform has very specific use cases. And so if people are asking specifically about the company overview, we will redirect the query to a pipeline that has been specifically engineered to handle the company overview well. If they are asking about anything else, then there are other types of pipelines. Really quick, going through the architecture for the Fitch Ratings Pro, which you'll see in a minute. Whenever new research reports come in, we have a chunking and embedding service that gets stored in Elasticsearch. I don't remember exactly how many different intents we are classifying right now, but here I'm showing 3 examples. You can ask for a summary about a specific entity. You can ask general Q&A for an entity, or you can ask for a unrated entity, questions that are specific to unrated entities. All of these get routed to different pipelines. Each one of those pipelines, like I said, calibrated to handle that particular type of question. You get the retrieved context, you get the answer that's generated, you send it to the user. In parallel, you're also running the guardrails. If the guardrail at any point determines that this is an inappropriate question, you cut off the rest of the pipeline and then you send any type of guardrail answer. This goes into a little bit more detail, but I'm running short on time, so I'm going to skip this one. Similarly, for the credit types implementation, we have the intent classifier and guardrails, retriever and generator. Here, one thing that we've done specifically is in the query expansion, we're also doing the hypothetical document embedding. This is something that we found to be very useful for the types of questions that users ask here. If anybody wants more detail on that, happy to talk about it. Why? Okay, this to me, this chart is really important. Why? Because this is iterative. We didn't get to where we are today from day one. For credit types specifically, we started at the end of February at the very beginning of the project with a very basic RAG implementation, the questions were taking like 30 seconds to get answered, and only about a third of the questions were being thumbs up from the user. Fast forward to late August, now over 80% of the questions are being thumbs up, and we're serving responses in less than 5 minutes. Okay, one thing that I want to show very quickly, and after this, I'll open it for questions. This is Fitch Ratings Pro. Let me go to this tab. So here, I opened up my Fitch Genie AI. I already pre-populated one of the standard questions. I got a response. The response will cite a source, and in this case, I have 2 particular sources. The question here was, can you provide 3 key ratings drivers for the recent rating change for Ireland? And if I click on those, I will see that it takes me to Ireland. This is the overall information page about Ireland, and I can see that there are particular metrics about the ratings, and it also cited the specific report that is the latest one from June of this year that has key rating drivers. Another quick demo that I wanted to show, and by the way, please start asking questions at this point. For a simple RAG and using an agent for a RAG, what are some of the differences that you can expect? In this agent, I have given it a scratchpad for memory, and I have instructed it to think about whether it already has enough information to answer the question that it needs to answer. And if it doesn't, it can rewrite the query to find additional information that it believes it still doesn't have. Using the simple RAG, I can ask questions about, and for this, I'm just using public company documents like 10Ks. Total revenue for Meta, Facebook in 2022, total revenue for Microsoft in 2022. And if I ask that question, I can see that it will retrieve some documents. And in those documents, it found the response. The revenue for Microsoft was 198,000 million or 198 billion. For Meta, it was 116 billion. However, if I ask what was the total revenue in 2022 for both Meta and Microsoft, it doesn't give me a response. Why? Because the chunks that it retrieved are all for Meta. It failed to retrieve any chunks for Microsoft. This is basically the pipeline and what it looks like. However, if I now give it agentic properties and I allow the LLM to decide the next action, it can go back and say, oh, you know what? I actually don't have enough information about Microsoft, so let me rewrite the query to make sure that I get that information. So here I asked the exact same 3 questions, and you can see that one of the things that happens is this results in more calls to the LLM, so this is more expensive. Again, it can answer the total revenue for Microsoft, it can answer the total revenue for Meta, and now it can answer the combined question. I can even send it a even more complex question asking about NVIDIA, Microsoft, and Oracle, and who had the highest revenue in 2022. And here I'm outputting every single step. So here the agent is making a decision, it retrieved some information, it updated the scratchpad. Now it has to decide, do I have enough information? No, I don't. So I retrieve even more information, et cetera, et cetera, et cetera. And it can answer with retrieved information about all 3 entities. Okay, and with that, I'm coming towards the end. And I do have one question. Could you elaborate on how you implement permissions? Yes, I can. When the user logs in, so I'm actually already logged in here into Fitch Ratings Pro. I'm a super user because I am a Fitch Ratings employee, but if I wasn't a super user, I can check against the database what document sets I have access to. In every single chunk, we include in the metadata which set that came from. And if I don't find the set for the user in the retrieved chunks, I eliminate those chunks from the context. I basically don't serve them. So that's it. The way we do it, it's filtering. And I believe we've come to the end, but if we have an extra minute or 2, I only have a couple of slides. Current limitations, they're all both technical and practical. The practical ones obviously being performance, cost, and do you have enough of a use case? these are very, very complex systems. And as you can see, for one of the ones that I demoed today, we've been working on it for basically the last 8.5 months with a team of about 5 to 6 engineers. That's a lot of resources. So make sure that you are going to have enough users if you're going to put that amount of resources into developing these systems. For next year, for 2025, we actually want to do a generative AI platform. Every single system that I showed today required a lot of custom engineering. We want to develop almost a plug and play system where any business unit within Fitch can come in with their own knowledge base. And even if you don't have specific, you will still need some technical people, so you will need engineers, but you don't need machine learning expertise or data science expertise. We're basically providing these tools almost plug and play. You bring your data, you bring some sort of user interface, and we will provide everything else so that you can get going quickly. Our goal is to get a similar application to credit sites from 8 months of development before releasing it to beta users down to to less than a quarter, so essentially less than 3 months. And then finally, summaries and takeaways. So know your data. You need clean data. I mean, this is no different than for any other machine learning application. Know your basic RAG components, but also know that vector search is not a silver bullet. Like I said at the beginning, you might need metadata, you might need filtering techniques, you might need agents in order to go back and retrieve additional context. The 3 major applications that I talked about at Fitch, the main challenges that we have seen are computational needs. This needs a lot of engineering. I know this is a data science conference, and typically data scientists are not really engineers. These systems do need a lot of engineering in order to make them run with acceptable latency. Future proofing, I mentioned this before. Make sure that each one of your components is scalable and modular. So if something new and cheaper and faster comes out, you can substitute it with that cheaper and faster thing. But also make sure that you don't spend a quarter and 3 engineers developing something that 2 people are going to use. You know, make sure that you're adhering to return on investment thresholds. And lastly, more complexity isn't always better, and that's why I showed 3 different systems. But unfortunately, the state of the technology is such that it's still necessary to do a lot of custom development in order to make RAG work in business use cases at scale. All right, and with that, if there's any more questions, please put them in the chat. Or if you think your question might need some kind of discussion, please feel free to follow me on LinkedIn. If you just type my name, you will